Good morning, student. This video is to discuss the question of how many solutions you can get when you are solving a linear equation. Okay, so here we go. So linear equation, number of solutions. So first, what is a linear equation? You have been solving linear equation for a while, but what is it? A basic definition of it would be that a linear equation is an equation in which each variable has an exponent of 1. Okay. Of course, you will not see the exponent of 1 because when something is raised to the power of 1, we don't put the 1 there, right? So the graph of a linear equation is a line, okay? That's where the word linear comes from. Okay, there are linear equations with one variable, like this one, 3x plus 4 equals 7, or we also have linear equations that have two variables, as we started to see soon already, right? You have been graphing linear equation in this format right here, y equal mx plus b, that we call the slope intercept form. Those are also linear equations, right? So let's move forward. How many solutions can a linear equation have? Okay, this is the question that we are trying to answer in this video. Okay, just note that there are only three possible solutions for uh, any linear equation that we are solving, right? A linear equation can either have one solution, okay, no solution, or infinitely many solutions, right? So those are the only three possibilities when we are solving a linear equation, right? So let's move forward. Now I'm going to explain this in two ways. One way is the algebraic explanation of the number of solutions. Algebraic explanation means that if you decide to solve a linear equation, okay, what are the possibility you may have, right? So first, let's discuss the situation where we have one solution, right? Okay. When we have one solution, if you start solving the equation, of course you are going to get one solution, right? You'll see that the variable uh, x in all of these cases will stay, right? We already learned to solve linear equation. I put this example just as to illustrate the point. So I'm going to subtract 7 from both sides. That's how we solve it. Okay, so I would have 2x equal 8 minus 7 would be 1. So if I divide both sides by 2, I would have x equal 1 half. So here it is, the one solution that will make this equation, the x value that will make this equation true, right? Same thing with this one, okay? I suggest that if you have a variable on both sides, and each side is already simplified, you just move the variable on one side, all right? I'm going to get rid of this 4x by subtracting 4x from both sides, okay? 4x from both sides. So 5x minus 4x, you have 1x, and we don't put the 1. 1x minus 1 on this side, and on the other side, the 4x are gone. So I just have negative 1 left. And I can add 1 on both sides. Okay. So plus 1, okay, and plus 1. So if that happened, negative 1 plus 1 is 0. So I am left with x equal 0. Okay, I put this example here on purpose, right? Remember, having x equals 0 as a solution tells tells you what? Okay, it just simply tells you that that's your solution. It's still one solution. Zero can be a solution, right? Zero is a number, remember, and x equals zero, meaning that this will be true when x is zero, right? So the solution x equals zero and no solution are not the same thing. They are completely different. Okay, so let's move forward. Now, when we are solving a linear equation of one variable, okay, and the variables disappear, okay, algebraically, okay, that is telling us that we have either of the following situation. Either we have no solution, okay, or we have infinitely many solutions. Okay, so those are the two situations we may have. Now let's take the situation where we have no solution. If you have no solution, okay, that means if uh, you are solving your equation algebraically, you are going to find out that end up with something that is a nonsense, right? That doesn't make any mathematical sense, uh, and an equality that is not true, right? For example, this one, 3x plus 9 equal 3x minus 4. If I decide to move the x, let me change color a little bit. If I decide to move uh, the x's on one side, I would have to subtract 3x from both sides, right? Minus 3x minus 3x. So that make this side, the x's are gone, all the x's are gone. Anytime that you have this situation where all the x's are gone, okay, remember, you are dealing with a situation with either no solution or infinitely many solution. Now, how do you make the difference? Now, on the left side, what I have left is 9. And on the right side, what I have left is negative 4. Okay. And you can see that 9 equal negative 4 is not true, right? That is a nonsense, right? So that's help us conclude that what we are dealing with is uh, a situation with no solution, right? Okay. So I can stop right here. If you decide to continue by adding 4 on both sides, you are going to get what? 13 equals 0. That still doesn't make sense. So here is another situation. Now, notice if you started with something that is with variable on both sides, make sure that you simplify each side before you decide to move the variable. So I'm going to leave the left side as it is because that part is already simplified. And the right side, I'm going to multiply, use the distributive property to multiply negative 7. So negative 7 times 3, that's negative 21. And negative 7 times x, that's minus 7x. Okay. Now, from this, if I decide to move the variable on the same side, I would have to add 7x to both sides. Okay. So you'll notice that again, in this situation, negative 7x plus 7x is equals 0, and negative 7x plus 7x, that's add up to 0. So I have 2 on the left side is equal to negative 21. Again, that's not true. So that's a nonsense. Therefore, we have a situation of no solution. Right. So here is that's these two examples were to illustrate algebraically when you have uh, a situation where your linear equation has no solution. Right. Now let's talk about the situation where we have an infinite number of solutions. Now, a linear equation with infinitely many solutions, when you try to solve that type of equation, you are going to find what are called and equality that is factual, meaning that is true, right? For example, something like 0 equals 0 or 5 equals 5, or uh, you can put any number that is equal to it. So here are two examples to illustrate this. Okay. Uh, let's say that I'm solving this. Both sides are already simplified, so I'm going to move the variable on one side by subtracting 6x from both sides. But you can always say that 6x minus 2 is always going to equal to 6x minus 2, no matter what x is. So that can tell you right away this is infinitely many solution, right? But let's go ahead. Let's say that you did not see that, and we subtract 6x from both sides. So 6x minus 6x, that's 0. And 6x minus 6x is 0. So on the left side, I have negative 2. That is equal to negative 2. And this is always true, right? That's a factual equality. That means it's always true. Then from here, you'll recognize that you have infinitely many solutions. If you decide to add 2 to both sides, you end up with 0 equals 0. Again, that would always be true. Now, let's look at this one. This one, we might need to simplify the other side first. Okay. So distributive property, 2 times x, that's 2x, and 2 times 2, that's 4. Again, you can see that 2x plus 4 would equal to 2x plus 4, no matter what x is. But if you don't see that, let's move the variable on both sides by subtracting 2x. And you can see that we cannot, because the variables are all gone. And we end up with 4 on the left side equal to 4 on the right side. And this situation is always true, right? So if you end up with a situation, okay, that is a factual equality that is always true, then you can conclude that you have an infinitely many solution. But as I said before, you can actually recognize that situation uh, when you have the same exact expression on the left and on the right side of your equal sign, right? If there's no difference between them at all, you already know that you have an infinitely many solution. Now, here is another take about how to identify um, linear equation with uh, one solution, no solution, or infinitely many solution. I call this the graphical approach of this of that concept. We have been talking already about linear equations, and we said that they can be written in the format y equal mx plus b. I want us to focus on the mx plus b part. So I want you to open uh, your mind a little bit, so that when you are looking at a linear equation, don't just see a single equation, but see it as two equations combined, right? Basically, we are trying to figure out. Uh, First, let's talk about the one solution situation, right? So, I want you to see that the left side, uh, this left side right here, okay, you can look at it as y equal 2x plus 7, okay? And the right side of the same equation, this 8, okay, we can look at it as another line that has the form y equal 8. So basically, solving this equation is finding the point of intersection between these two lines. All right, that's what the solution is, where the line y equal to x plus 7 meets, crosses the line y equal 8. Now, what is the slope for this line, y equal to x plus 7? You can see that the slope is 2, m equal to, let me put m equal to, that's the letter we use for slope. Now, equation that has the form y equal b are horizontal lines, right? Equation of horizontal line. That means the slope is 0, m equals 0. So you can see that the left side of the line on the left and the line on the right of this equal sign do not have the same slope. Anytime that you have that situation, then you are dealing with one solution. Okay, so one solution. Okay, when the slope of the line on the left side of your equal sign is different from the slope of the line of your equation on the right side, you have a situation of one solution. Based on that, we can always tell that 5x minus 1, okay, guess what? The slope is there. The slope there is 5. On the left side, the slope is 5. On the right side, the slope of that line is 4. So different slope, okay? Even though they have the same y-intercept, the slope are different. Therefore, we are going to say that these two equations actually have one solution. So that's a situation we want solution because the slope are different. The idea is if two lines are growing at different rate, they are bound to cross at some point because lines are infinite, right? So only parallel line do not cross. If lines are not parallel, okay, then the line will cross somehow. Whether it's close or far away, they are going to cross if they don't have the same slope, right? So that's the idea. Okay. So here is another situation. Let's talk about when the slope is the same on both sides. Okay. If the slope are the same on both sides, then you have to compare the y-intercept, right? If the y-intercept are different, then that means you are dealing with parallel line. Okay. Parallel line changes at the same rate. Okay. That's what explains the slope being the same. But if they don't have the same y-intercept, that means the line are distinct. They are different, right? That means those lines will never cross. Hence, we do not have a solution, right? Same slope, different y-intercept, no solution. Okay. So here it is, right? We have the slope on the left side is 3, and the slope on the right side is 3. That means the slope are the same. Now, let's look at the y-intercept. Okay, the y-intercept on the left side is 9, and the y-intercept of the line on the right side, that's -4. Therefore, since the y-intercept are different, then we can conclude that this is no solution. Those are parallel line, no solution. Okay. Now, this you may not see it right away, but when we simplify it, you can say that this side, let me change color a little bit. So we have -7x plus 2 on the left. If we use the distributive property, we are going to say get -21 minus 7x. Okay. Now I'm going to this part, the left part is already in slope-intercept form. I'm going to write the right part in slope-intercept form, meaning that I'm going to write a -7x first, right? -7x minus 21. Okay, so you can see again, we have the same slope. which is -7, and different y-intercept 2 right here and -21 right here. Therefore, we can conclude that these are parallel line, and parallel line never intersect. Therefore, there is no solution, right? This is a situation with no solution again. Okay. Now, let's talk about the situation where you have the same y-intercept, same slope. Okay. So, same slope, 6. The slope is 6 right here. The slope is 6 right here. The y-intercept is -2 right here and -2 right here. They have the same slope, same y-intercept. That means this line overlaps. That means they share infinitely many solutions, right? Many point together. So in a case where you have the slope and the y-intercept being the same, then you have infinitely many solutions. Okay. Okay. Many solutions. And those solutions are infinite forever, right? Here is the situation again. 2x plus 4. Let's use the distributive property again. You'll see 2x plus 4. So 2x plus 4 on the left is equal to 2x plus 4 on the right. So again, same slope, same the y-intercept are the same. So this is a situation with infinitely many solutions, right? Now, you may use a graphing tool just for you to see those type of situation, right? Why don't we see the graph of one situation where we have one solution like this one, a situation where we have no solution, and a situation where we have an infinite number of solutions. So I'm going to go to decimal graphing so that you can see it. So one of the line is 2x plus 7, okay? And the right side is y equal 8. So 2x plus 7 and y equal 8. I'm going to decimal right now. That's a graphing tool. So you have to put y equal to graph a line. Y equal 2x plus 7 and y equal 8. Okay. So those are the 2x plus 7. That was the left side of one of our equation, and y equal 8. That's was the right side of the equation. And you can see right here, this is the solution right here, right? So the solution is what? The x value is what? Okay, that means these two sides are equal when x is 1/2. And if you replace x by 1/2 right here, 2 times 1/2 is 1. 1 plus 7, that's 8, right? So in that situation, when x equal 1/2, the two sides are equal. That's what solution mean. Okay, the x value when where the graph intercept. Okay, so that's an example of a situation with one solution. So let's look at this situation right here where we have no solution. So that's 3x plus 9, okay, on one side, and 3x minus 4 on the other side. So 3x plus 9 and 3x minus 4. 3x plus 9 on one side and 3x minus 4. Okay, so you can see the two line. Okay, let me zoom out. These are parallel line. This line will never cross, right? Therefore, since there is no point of intersection, they will have no solution. Okay, no solution. So let's compare the last situation where we have infinitely many solutions, right? So I'm trying to get out of this. So we have 6x minus 2 and 6x minus 2. So 6x minus 2 and 6x minus 2. 6x minus 2 and 6x minus 2. Now, it's hard to tell, but you'll notice that you cannot even see two lines, right? Because the lines are overlapping. That means they are on top of each other, right? If I cancel this one right now, okay, you can see that the first line is actually red, right? Now, the second line is supposed to be blue, but because it's on top of the other line, you cannot see it, right? So that's a situation where they share all the points in common. So we have infinitely many points that they share in common. So that's called an infinite number of solutions. Okay. I hope this helped. I'll see you in class.